Thanks for bearing with me, everyone. My name's Cole Tomlinson. I'm an Android developer at Atlassian on the Trello app, and I'm going to be talking to you today about drag and drop and compose. This is something that's taken up like the better part of the last 2 years of my professional life, and I'm going to try to distill down into a 20-minute lightning talk for you, or maybe even 15 minutes now that we've got a little less time. How do I advance? There we go. Cool. All right, high-level plot arc of this talk real quick. First, we'll get aligned on what drag and drop is, why it's important to Trello, and why we need to do it in Compose. Then I'll get into the initial approach that I went with that I call the pointer input method and the technical details behind that. Then the merits and pitfalls of this pointer input approach and why I ultimately had to go back to the drawing board and come up with a new approach. Then getting into that second approach that uses the compose drag and drop APIs to solve those pitfalls, and finally some forward-thinking improvements that I'd love to see happen about how things can get even better. So what's drag and drop? Drag and drop interaction for the purposes of this talk is a UI interaction where you long press on something with your finger, aka your pointer. I'll use those terms interchangeably in this talk. That starts the drag operation, usually has some UI indication that you've started the operation. Then any movement while you've got your finger down moves the UI element with your finger, and then lifting your finger drops the element. So in this example, long press on pizza, drag it to the mouth, and you get a toast that says yum. If you're not familiar with the Trello app, here's some screenshots showing off the ways that we employ drag and drop. You can drag and drop all types of models in the Trello app. You can rearrange cards among other cards and in between lists. You can rearrange lists among other lists, and it'll bring the contained cards along for the ride. You can rearrange check items. You can rearrange checklists. All that is to say that different models can have different types of drag behavior, and it's important that we account for that flexibility in whatever solution we come up with. It's a very important UI interaction for our app to nail. It's something that our users have come to expect to be like quick, intuitive, very polished experience to do things quickly. So why'd we need to get it done in Compose? The folks who wrote the initial drag and drop implementation of the Trello app did some really amazing work, but it was tightly coupled to legacy views. I don't fault them for that at all. It was written like a decade ago, and there was no way they could have predicted the coming of Jetpack Compose. There's some really smart people, and I love them a lot. But on Trello, we're trying to be a modern Android app, adopt all the new hot UI frameworks and everything. So we needed to quickly come up with a solution in Compose. That became my problem to figure out. And I quickly found that dragging and dropping even static UI poses enough of a challenge, but making this happen in a lazy column with like X amount of items and different types of models with different rearranged behavior, there was no precedent for that in our project, and no like out-of-the-box APIs from Compose, and not even something I could find too much discussion about online. But this brings me to the initial approach that I refer to as the pointer input method. After a ton of searching, my prayers were kind of answered when I happened upon this lazy column drag and drop demo in the Android X code base. I think I found it mentioned on like an issue tracker, and then went and looked at it, and I was like, oh, this is awesome. This is like exactly what I'm looking for. It didn't give me exactly everything I needed out of the box to get checklist and check item rearranged done, but it gave me that primitive of like, hey, here's some items, here's how you rearrange them in a lazy column. And I call this one the pointer input method because that is the modifier it uses to recognize gestures. So how's it work? It's got three main components. I'll expand upon these further in the coming slides. It's got a drag drop state that has knowledge of the lazy list state and has its own state variables that it maintains to facilitate the operation. The pointer input modifier that handles all the gesture detection needs, and then the graphics layer modifier that gets applied to the dragging item to give it a little bit of like visual distinction compared to the other items. So all these work together to achieve a lazy column with rearrangeable elements. You can see long pressing on item 1, you can drag it down the list. Items rearrange as it moves down, and then you drop it wherever you want it to go. It's great. Getting more in depth into those three pieces, so the pointer input modifier gets applied to the entire lazy column. It uses this out-of-the-box compose detect drag gestures after long press gesture detector, which is a mouthful, but does exactly what it sounds like and gives us the callbacks that we're interested in to facilitate a drag and drop. On drag start, on drag, and on drag end, they all do exactly what they sound like. They include like an offset with an X and Y dimension at the time that they happen. Getting into the drag drop state, this is like the brains of the operation. It has knowledge of the lazy list state and has its own state variables to facilitate. So it will take events from the pointer input modifier, use those to start, continue, or end a drag, and crucially, it will make decisions about when to trigger a rearrange in the underlying data set. The most interesting functions on drag, which handles updating the state variables. There's this dragging item dragged delta state variable in the drag drop state that like maps to the translation Y parameter of the graphics input modifier that I'll get into on the next slide. And it does most of the consequential math to trigger the rearrange. So the way it does this is looking at the lazy list state's visible items info. That's a collection of all the visible items that are currently on screen at that point in time, and it's got information about their layout, like their size, their index, where their offset is from the start of the lazy column, and then it can use that information to make a call on when the dragging item should rearrange with what's underneath it. So in this GIF, the rearrange condition is the midpoint of the dragging item overlapping with another item? If so, then switch their spots. So you'll see item 0 is the one being dragged when its midpoint is over top of item 1, then they switch back and forth. You can get fancier with that, but for the purposes of like a simple example, that's an easy one. And then finally, the third piece is the graphics layer modifier. This is a really powerful modifier that does cool things for very minimal effort. You saw on that last slide, we were just updating translation Y to move the dragging item straight up and straight down in the Y dimension. But while we're here talking about the graphics layer modifier, just wanted to highlight a few quick ways that you can easily give even more of a distinction with it with just some like easy one-liners. So it's trivial pretty much to add X translation as well as Y translation because every call to on drag gives you an offset with an X and Y offset. So you can move side to side and up and down and just reinforces that like finger to UI connection. Something else we can do is add a little bit of opacity that more easily helps you see what is underneath your dragging item, which is particularly helpful with like a big one if you've got lots of items underneath and you want to see exactly where it's going to land if you end the operation. Then something we like to do on Trello is add a 5-degree Z rotation, which just gives like a little bit of extra visual distinction. So let's talk about what's good and what's bad about this pointer input approach. The good is that it was largely successful. We shipped this out on the scale to millions of users with the checklists and check items feature. We rewrote our card back in Compose. The drag and drop interactions felt pretty high quality, and it was flexible enough to allow for different types of models that you're rearranging. What is not so good is that while it worked great for checklists and check items, there are a couple key limitations that we thought about bringing drag and drop and Compose to other parts of our app. The first one is that the graphics layer modifier is a canvas that's scoped to the parent of the containing composable. So in this case, that's your lazy column. If you try to drag outside of the lazy column, then the item gets clipped. You can see in this GIF on the left, dragging that item to the other list or to the drag target up top just like clips it. So that would be a non-starter if you wanted to have functionality like that. And then the on the right-hand side, the reliance on visible items info to get that layout info of the dragging item and using the graphics layer modifier to manipulate the actual source item means that the source item must stay on screen at all times during your drag or it's going to completely bust your drag operation. Something we found that made us sad was like if you have a really tall item down at the bottom of the screen that like is partially on screen, then you get to that rearrange condition and they rearrange, then the dragging item actually gets knocked out of visible items info and the drag is bad. It breaks. We got around this by imposing a max height on our dragging items during rearrange in checklists, which was okay because people don't make super tall check items, but it just feels bad. You ideally want to be able to handle arbitrarily tall items. So this brings me to the second approach to address some of those pitfalls with the pointer input approach. Enter the drag and drop source and drag and drop target modifiers. These dropped in Compose 1.6, and we found that they can do a lot of heavy lifting for us, particularly around handling the drag input, so we don't need the pointer input modifier anymore, and drawing the dragging item, so you don't need the graphics layer modifier anymore. It basically trivializes implementing a basic drag and drop UI with like static items. So back earlier in the slides when I had that dragging the pizza to the mouth demo, you could spin that up in like a minute just by dropping a drag and drop source on the pizza, a drag and drop target on the mouth, and then you say what you want to happen when the drop happens. But there are still some challenges that remain when you're thinking about making this happen in a lazy column. It's not fully out of the box in that situation. But luckily, you can pretty much wire up the drag and drop source and drag and drop target with a paired back drag drop state from the pointer input approach and get things pretty close to working pretty quickly. Don't worry too much about that GIF on the right yet. I know there's some things wrong with it. But the way it works is the drag drop target modifier gets applied to the entire lazy column and it is like a pseudo pointer input modifier for our purposes. Then the drag drop source modifier gets applied to every item in the lazy column. It uses that detect drag gestures after long press gesture detector, but we only use the on drag start callback, and then we hand it off to the APIs and say, hey, start the transfer. and then it handles the rest. So the paired back drag drop state only needs the on drag function now and doesn't need to keep track of its own offsets or anything, since we get that for free from the APIs. So you can see it works pretty well just dropping it right in here, but you notice that when you pick up item 0, it gets duplicated, and that rearrange math is not quite right. Like there's some weird offset to it. And this turns out to be due to some differences between the pointer input modifier approach and how the APIs work. The issue with the rearrange math being slightly off is just due to the on-moved callback in the APIs receiving global window coordinates about your pointer rather than local coordinates. We can pretty easily just handle this by converting to local coordinates by looking at the lazy columns layout coordinates. And then you see in the left-hand GIF, the math is fixed up, but we still have the duplicate item. And the issue with the duplicate item is because the APIs handle rendering that ghost item for you. So the ghost item and the original item in the data set are showing. Under the hood, the APIs are making this happen actually by anything that it has a drag drop source modifier applied to it, has a picture taken of it, and then the APIs will render that picture to the screen, and that's how they get away from that limitation where you can only render within the source parent, so you can drag anywhere on the screen. So we can fix that just by using a on draw and then not drawing the one if we detect that it's the one that's being dragged at the moment. Yeah, the APIs really rock. This is a GIF of a new feature we rolled out on Trello called Inbox, and the drag and drop APIs allowed us to move forward with a lot of the features that are in it. You can see when you pick something up, there's a few drag targets on screen that reveal themselves. There's the archive one at the top, the move ones down below. You can drag to any of those, and you can put a drag drop target on like really anything you want. And because the ghost item is no longer bounded by the source's parent, that can go anywhere on screen. It can get dragged outside of the lazy column, and it's great. And then since the APIs handle the ghost item, we can completely decouple from using visible items info and that graphics layer modifier. And you can see that I'm over scrolling over top of a really tall item, and when they switch spots, the drag still happens. So that's super nice. So things are in a really good state now with these APIs. We're able to do pretty much everything that we want, but I do have some ideas on how things could get a little bit better even moving forward that I'd like to share real quick with you. Gonna plug some issue trackers here real quick, and I have some QR codes if you want to check them out, or like +1 them if you want to. But the first and biggest one is that the drag and drop target modifier will only receive events about the drag if it is in composition at the time when the drag starts. So if you are in a situation like in that last GIF where you pick an item up and you start moving it to the top of the column, new items enter composition on screen as you scroll, and you want those to receive events about the drag, you cannot do that. They need to have been in composition at the time when the drag starts. If that was resolved, my big idea is I have a dream of a future where I think you could apply the drag drop source and drag drop target modifier to like any item in the lazy column. And then that would give you enough contextual information that you could make that rearrange decision right there in the callbacks, totally get rid of the drag drop state. And I think that would get us really, really close to like an out of the box solution for rearranging in a lazy column, which would like invalidate my whole talk, but that's a good thing at the end of the day. Second improvement idea I have is there's this draw drag decoration optional parameter with a drag drop source. It allows you to customize the ghost item, but the canvas you have to draw to with that is like very tightly bound to the size of the original composable and its position. So if you wanted to do something like I showed in the graphics layer pointer input approach where you rotate 5 degrees, it clips the corners of your ghost item, which is not great. We worked around this in Trello by doing some like programming sins and copying source and expanding the canvas manually that I'm not going to show you, but it would be really nice to have out of the box support for that to get like arbitrarily sized ghost items. That is pretty much it. Thank you so much for coming to my talk and hearing me ramble about drag and drop and bearing with my poor connection setup issues. I do have a GitHub repo that illustrates getting this done with the APIs and pointer input. And if you want to chat with me more about this at all, connect with me on LinkedIn. I can talk about this pretty endlessly. So let me know. I'd love to chop it up with you. Thank you.